Hi. Okay, finally on this snowy day finished upgrading all of your quadratic classes, okay? And there were so many consistent types of issues that came up. I wanted to make a little video and try and just point them all out at once so that everybody's on the same page. In general, they were really solid, really good. I think you're set to go. You have the notion of classes being the combination of data and methods and the basic structure for them in Java. At random, I've kind of just picked out Cecilia's here. I hope she's okay with this. Cecilia, I'm going to go through hers and point out all the things she did that were right, that were missing, or in and out on some papers. Okay, so first thing is right up here, this use of JavaDoc, okay? So I need you to start using JavaDoc. When you're in JGrasp, you're going to create a project, create your .java file, and then you can just go under project and say generate JavaDoc, and a complete HTML website of documentation for your class is automatically written for you. So you've got to start using these commands, at author, at date, at note, the /*, followed by a //. You'll see down here she's using at param, there's an at return. So all of this is documented in your appendix of your textbook. So take a look there, or maybe Cecilia will be very kind and post her file so you can get an example from a specific homework set. Now, another mistake folks made, you do not want every variable that you need in the entire program to be declared as instance data and fields for the class. You want the minimum set that are required to model that object, okay? So here, you've got to have an A and B and a C. That's all. Once they're specified, you have a quadratic equation. Now, Cecilia called them the quadratic coefficient, the linear coefficient, and the constant, because she's probably done a little bit of math recently, because these terms are in her mind, so that's a good way to do it. But it's fine if we just say ABC. But I don't want to see the roots in here, the discriminants. Some people had, like, X, Y, and Z, and temporary 5 variables stored in here. You want the minimum amount of data, and then the others belong in the methods where they're being used. Let's see, constructors. You want to have a constructor. It should have the same name as the class. Normally, you're going to have at least 2 of them, okay? So I see only 1 here in Cecilia's paper. It would be good to have 2. So at least you've got to have 1 where you give the user the chance to enter A, B, and C. They should not have to be doing set A, set B, and set C calls to just start to use a quadratic. That's not a friendly, well-designed class, right? You know they're going to want to set A, B, and C. So you should have a constructor that allows them to set all 3 parameters. Then you should also have another constructor, typically a default constructor, quadratic paren, and you assign A, B, and C to reasonable values in that one. Okay? Notice that she's using this. And that's a really great simplifier, because now you don't have to play games and try and come up with separate names for each of these 3 parameters as compared to how you've named them in your instance data. You can just say this quad equals quad, this linear equals linear. If you had done ABC, this dot A equals A, this dot B equals B, done. Okay, so use this in your constructor, have at least 2 constructors in a class. Then we go to all of the sets, and they're pretty standard. All of the gets, remember the gets are going to return values. Watch your data types. So some people inexplicably made A, B, and C be integers. There's no reason for that. I could very nicely have a 2.3 as a coefficient for my quadratic. So you've really restricted the usability of your class when you do that. So be very mindful of data types. Let's move on. Here's a problem a lot of people had. When you calculate the first derivative, it's dependent on where you are in that curve, which x value you're feeding in. Okay, that's not something that you as the class designer have control over. That's going to be passed in by the user of the class. And that's how you know it's a parameter. Okay, it's a parameter when you as the class designer can't possibly assign it a value. You don't know. It's information from the outside world, okay? So the computation of the derivative was dependent on x. That had to be a parameter. So x comes in, and we return a double out of that one. Here's something that I really wanted to see everyone doing since we had just come off ArrayList, and not many people picked up on it. You're computing 2 roots, right? You can only return 1 at a time with the word return. So almost everybody arbitrarily created 2 methods with crazy names like get root 1. If I'm a math major and I know I run a quadratic, what's root 1? I don't know what root 1 is. There's nothing called root 1 in math, right? What you wanted to do was use a list and not return a double here, but return an array or return an array list, since we just spent a week learning about that. Or I think it was Thomas who got really cool and started using something like a hash set, okay? Returned a hash set, but some kind of container that can hold more than one value. So here they are being calculated and returned, calculated and returned. Here's another thing that came up for people. If you have method names like, is this a negative discriminant? The answer should be Boolean, yes or no, true or false, not a string. Stop using strings. Everyone comes out of 111 so string crazy, right? You're printing. I'm telling you that almost never happens. I'm fine if you never have a print statement in your driver or your class, certainly not in your class. As soon as you put a print statement in your class, you've restricted the usability. Only certain people are going to want a print statement that looks like that. So methods do not talk to each other with printing. They talk to humans with printing. Humans slow things down. Methods talk to other methods by returning values, okay? So if you need to have one place a toString method, which also does not print, but it returns a string. So that's the one chance you have to indulge all of your formatting happiness and create a huge string constant, a huge string variable out of the different pieces that you want so that a quadratic is displayed as a string. Now when you go to use toString, remember you don't have to explicitly say .toString. It's invoked automatically by the print method. So if you have a method called little to, big S, tring, that's what print and println are looking for when they come to your class. And now you can just print variables that are of type quadratic, okay? So don't make up some new name for the toString class. Have a toString class in every class, have it be exactly named toString, have it return a string, and you'll be much better off. So I think that's basically the full set. Everybody had a driver. Everybody tried to do some testing data, so I'm very happy we're moving forward in that. The Booleans for is real root, is negative discriminant. I think that's pretty close to the full set of comments I had. Okay, so hope the video helps. If you have questions about this, even though we're moving ahead into other data, please come back and just let me know on the boards and we'll stay in touch that way, okay? Hope you're enjoying your snow day. Probably the last one of the year, but it's a good one. All right, take care now.